Good. All right. Well, thank you.
It's really a pleasure. I got it, Tom. You are one of the ones I've always enjoyed hearing, whether it be at NAB or in person. There is, as I wrote, few people, design, installation, inspection, construction. You've done it all, and you've done a job that everybody really appreciates and looks up to you. And so I'm really thrilled to have you here today. So over to you.
Thank you for saying that. That was very kind of you. When I was at Cornell before I went to my get my master's degree after 5 years of undergraduate bachelor of electrical engineering, I moved out to Indiana for the summer and designed an antenna system for Houston for 9 Class C FM stations. And ERI got the contract about the time I got my master's degree. So that's how I got hired. And all the engineers in the industry were mad because this kid in college designed this largest FM system in the country for 9 Class C FM stations. And they couldn't believe it, but it was a very successful project and it worked for years until it was on the shell building. Eventually, other buildings shattered it. So that's how I got started here. I want to talk about towers today. The the TIA standard for inspections is 3 years for guide towers. Every 3 years they should be inspected, and 5 years for self-support towers and mounted poles. So they should be inspected, and to be inspected, they analysis needs to be done on a similar program to TNX Tower 8, which is what we use. And I want to spend a few minutes before I really get started on this talking about those standards because it's really interesting. The original standard for towers designed for FM and TV in the United States of America and the world for that matter was all done with beam column calculations. And the uh, the the problem we ran into a problem in upstate New York one year where there was a 900-foot tower on a site that was shared with an AM tower. So the 900-foot tower, which was made by stainless, was sectionalized to avoid interference with the AM. So there was a set of oil-filled Rackle Deca insulators at 400 feet and another set at 800 feet and then another set at the bottom of the tower to keep it from resonating at AM. So one day, the engineers came out and one of the insulators at 400 feet was gone. And the tower dropped down about an inch and a half and went about 9 inches to the side with that open hole in one leg. So everybody was trying to solve this problem, but every time it would go to a crew, the tower company would say, "We won't climb it, but we will drop it for you." And then they said no. And then finally their consultant, which was Don Everest, called me up and he said, "Can you look at this, please?" And I said, "Sure, send it to me." So he sent it to me and we got together and looked at it here. And Ernie Jones was alive then. And Ernie and I and John Robinson went over it. And the problem was the beam column wouldn't calculate deflections. And this was a real problem. So we went to Dan Horn, who was a building designer in Milwaukee, Wisconsin, who I knew really well. And we asked him if he could model that tower in his program that he uses to design buildings, because buildings have to be able to measure deflection. So he said he thought he could, and then he did. And basically we set up a camp here at the office, and his program took 4 hours to run. And we ran it over and over again until it finally converged. And then we had the tower surveyed as part of the whole thing. And his program predicted the deflections, and it also gave us the load that was in the on the other insulators. So then we went back to the insurance company and said, "What, we need to go to Raquel Deca and have them break an insulator." So we did. And it turned out that the tower was actually mathematically safe to work on with up to a 40-mile-an-hour wind trying to push it over. So we went back and we said, "All right, I'll bring a crew up there and we'll have a capstan because I don't want to rig it with wire. We'll rig it with rope. And what we'll do is I will climb it alone. So if somebody gets killed, it'll be me. And then if it feels safe, then I'll bring the other guys up and then we'll work." And then we had a stainless engineer there as well. And so I climbed up there, and it turned out the day that we got there, the wind was actually blowing the opposite way, so it was like making the tower stronger. So I climbed up there and I walked around up there, and it was fine. So I jumped up, called the other guys, and had them come up, and we brought up what we needed. And then we rigged it with the rope, and we brought up a frame that stainless design that would allow us to have that would go to the legs above and below us, and have a gap where we could put where we'd have two jacks and a hydraulic pump, and then the gauge would read the actual force. And we knew that we needed the computer program said we needed 8,000 pounds to pick the tower up. And when it started getting up to reading 8,000 pounds, we could feel us moving over each pump, as the tower moved. And then we jacked it up and put a metal spool in there. And when we took the old plates of the Raquel insulator off, because the glass part was gone, but the top and the bottom was bolted to the legs. But we had an aha moment, because when we took the top piece off, all this oily water came out. And we realized that stainless didn't put weep holes in that leg above the insulator. So the leg slowly but surely filled with water and finally froze one day, and the pressure broke the seal, and then the oil came out and the water went in, and then they had another freeze and it broke the insulator. So anyway, we fixed the tower and everybody was amazed. And I remember they had a guard there. And when I showed up to climb the tower, the guard said, "Excuse me, you're going to climb that tower?" And I said, "Yes." He said, "You're an idiot, aren't you?" And I said, "Yeah, I've been called that, all worse." So when we were done, and of course, this program was so powerful. So we went back to the guy that designed the program in Wisconsin, and we said, "Can you make a program for a broadcast using this deflection program?" And he said, "I'll do it for $40,000. So I told Ernie, I said, "He won't do it for 40,000." He said he will. Why you keep saying he won't? I said, "Because he won't. Just send him the 40,000." So we did. About a month later, he called back and he said, "I can't do it for 40,000, but if you let me own the program, I'll pay you 40,000 back on commission, and you can use it for free for the rest of your life." So we, to this day, are using the design program for free. So the program we use to design towers today does measure deflections, and it came from me. So I'm very proud of that. And then the other program that came out of that same period of time was the program to do gin poles. And it turned out that people were using gin poles that companies were making, but there was no standard to design them. And so I needed one for Pittsburgh. So I went to Ernie, said, "I need you to design and build me a gin pole." And he said, "I can't, I don't know how." And I said, "What do you mean you don't know how?" He said, "There's no standard for gin poles." So we got with Nate, and a gin pole standard was designed at our factory here in Chandler, Indiana. And we set up models, and we had a college professor working with us from the University of Evansville, Dr. Lott. And we built a little model for him in our lab. It's about 2 feet tall, just a little tiny thing, but then we had little little piece of wire going through the middle, little pulleys at the top. And we were playing with it. And all of a sudden, Dr. Lott goes, "Aha." And I said, "What do you mean, aha?" And he said, "I just realized why these gin poles that are being made by people with no standards are not killing people. I said, what's that? He said, the reason is that the wire goes through the middle of the gin pole. It goes over a pulley and then out to the side over another pulley and down. So the more weight you put on the wire, the more back moment you get from that pulley at the top. So that's what saved everybody's lives. Nobody knew that. So it was just dumb luck. But at any rate, so the standard for gin poles and the standard for tower design both came from me. Now, enough babbling about the standards, but it's kind of neat the way they formed. And by the way, if anybody has any questions, please let me know. So the inspections that should be done. I'll tell you one other story about that program. The Metropolitan TV Association of New York, which is the association of all the professional TV studios in the city, broadcast companies, they wanted to have their tower reevaluated on the Empire State Building. So they came to me and they said, can we pay you to do a thorough inspection and run this new program on the Empire State Building? And I said, yeah, I'd be glad to. Because, of course, as everybody knew at the time, the building the tower in the building was always analyzed by Cy Donner, who was a New York consultant. And so several of us got together and we spent several times climbing the tower and getting detailed at night, measuring everything, verifying every size until we got it all set and done. And then we took it back to Indiana and we ran it in our new program and then scheduled a meeting in New York with the head of the MTVA. And basically, the problem we ran into when we did the analysis was that the Empire State Building has very, very sharp tapers. So instead of like the bottom of a tower being maybe 15 feet and having a tapered, section down to a little point, their tapers were like 6 feet. Well, it turns out that when you make a very short taper like that, you add moments to the legs. And it turned out that the tower was way overloaded because of that. And those tapers were going to go. They were ready to fail. So we told them that. And there two things happened after that. First thing was that Cy Donner got fired. And the second thing was that they took it over to Thornton Tomasetti and we trained them on how to use the new program. And they bought it and they've been doing it ever since. So it is very interesting, the power of that program. The other thing it can do is that when we did this once in Colorado, was design a tower that if it lost a guy wire, it wouldn't fall down. So we used this new program to do that and everything and built the tower and sold it. It got put up and then about 6 months later, they came out one day and one of the wires had fallen off. And what happened was there was a hydrogen embrittlement at the anchor and the attachment, and it broke and the tower didn't fall down. So we went out and pulled the wire back and put it all together. But it was interesting that program can do that because it can measure deflection. At any rate, if you have, going back to what I started talking about, which was inspections of towers, if you have an inspection done, you need to take two things in mind. Number one is it's illegal now for a single person to climb, because when I started climbing, I used to climb alone all the time, but now you don't. You have to have two climbers minimum, and they need to be certified both in climbing and in rescue. And climbing inspections, climbing needs to be every 2 years retrained, and rescue every year. So what we do here at ERI is we have a certified trainer come in, Sean Cooper, North Carolina, and then we have a training area in one of our garages that has a tower that's mounted to the floor, has everything that's necessary for certification. So if you bring in someone to inspect your tower, they need to be certified to climb and certified to rescue, and you need to, and there has to be minimally two of them to go up and do the inspection. The inspections look for things like corrosion, uh, members that are bent, and of course they can also do another run of the analysis on the TIA standard, because a lot of older towers were designed with the beam column, and it's a good idea to run the new program on them to verify deflections and to verify safety and whatnot. And of course, at ERI, we actually have a division to manufacture and design towers, so we're very capable of doing those inspections. I've done many of them myself. Weird things we find with hollow leg towers, occasionally we'll find holes in the legs where the water moisture's built up on the inside, and they've eventually corroded the pipe. If it's a pipe instead of a solid rod leg. So it's always good to check for that. You can check for bolts and tightness and everything. And side mount antennas. Obviously, if you have an FM antenna or a TV antenna, ideally, if there's an aux, you have to switch over to the aux when the people climb through there, because there's exposure issues climbing through FMs. And then before they had the standard for that, I was famously known for writing my name with a wrench on antennas to say that I was there, and putting the date down so I'd burn it into the brass. And people would tease me about it. They'd say, "Oh, Silliman was here to shoot." But ideally, for example, if you have an aux lower on the tower, you can climb through the aux while the main's hot, and then you can get about 30 feet above it, and then just switch from the main to the aux, turn the main off, and they can go up and finish doing the inspection up top.
Tom, a
Guy
question? A question?
Does someone have a question?
Yeah. What level of power could you run without turning the transmitter off?
To climb through it, if you had a suit on, you could maybe run it at about 4 kilowatts or so for a 6-bay, for example. But ideally, if you have an aux, if we've done this many times, we'll climb through the aux and then have them get about 20 feet above it, and then have them turn the aux on and then turn the main off. But if you
I've had a number of people ask me about this, and also on AM. Of course, the wavelength on FM is much closer to resonating with the body than AM.
Yep. With AM, what we used to do is we used to put a little wooden ladder next to the base of the tower, climb up to the top of the ladder and reach over with a channel locks without any insulation on the handle, and grab the leg, and then that would bring your body up to the AM potential, and then climb onto the tower and go ahead and climb it. Now, they usually will reduce the power significantly before they do that. But you just have to be careful with RF exposure.
Would you say that you could climb a kilowatt AM or 500 watt without problems?
I wouldn't have a problem with 500 watts, but I'd have a problem with 50 kilowatts or something.
Yeah.
It'd be touched pretty good. But with FM, of course, the problem, as you said before, was that the FM wavelength is around 10 feet, and so you're people are closer to a half wave, and so you can have resonant current flowing on your body. So you just have to be careful. Any other questions out there?
If you have a question, press your space bar or alternate A to unmute and let Tom know what's on your mind.
The interesting thing is that when I started climbing, we were using a leather belt made by Klein and a leather lanyard. And the Klein hooks, even though they didn't have safeties on them, you couldn't roll them out because they were so tight. The only thing you could do is get your shirt caught in it, and then it could come out. And so then people started making belts with a current mantle rope, which is rated at 10,000 pounds, and huge hooks. And a good friend of mine, when they were changing the design of the belts, asked me if I would try a lanyard that he made because he was going to try to market it. And I was doing a job down in Florida, 500 feet, with another guy, and we got up to where we were going to have to do the antenna. And my plan was for him to have the tools that we needed, and I would be leaning out doing the work. And I told this guy I was with, I said, you know, I'm leery about these big hooks. I think I'm going to tie glowfish with about where I need to be in this belt, and then at least I'll have another backup. And when I first leaned out, I went, the outside hook rolled out. I fell, swung on that clove hitch, went whoop to the side, and whoop back, and shoot. Looked at him, and he was like, "Oh my God!" And I told him, I said, "All right, I'm going down to get my old belt." But but the times are changing.
Well, as you said, now you have to have two folks on the tower at the same time rather than
right.
one
With
guy.
in proper training, they should have cards in their wallets. They can show you that they're certified, and it's very important. And then, for example, they were putting a tower up in Kansas, and two of us went out there to inspect it, and they were because the crew said they were done, and so we went up. We were working our way up, checking things, checking bolts and everything else. We got all the way to the top and realized all the hardware was loose on everything up there in the last 40 feet. So I called down to the crew foreman and I said, "Hey, you need to send a guy up here with a wrench, and he's going to have to check all these bolts up here." So he said, "Okay." So I'm watching the guy come up, and he got about eye level with me. We were about 800 feet up, and all of a sudden he disappeared and went down like a rocket. And I looked out in the field, and here comes the winch. The winch was sliding across the field. It finally stopped. So the foreman went out and got a truck and pulled it in there to brace the winch, and then he winched the guy up to me. I told him, I said, "I'm glad it wasn't me on that load line." But I've seen that happen twice. Once there, and then once down in Florida when another crew was pulling up a gin pole, and all of a sudden their winch took off, and the gin pole worked its way down close to the ground. So I always tell people, if you're gonna have a winch on a site, make sure that winch is absolutely braced so it can't move. And if you can't put an anchor in, then pull a truck behind it and grab it. Do that route. It is interesting. Some of the things we did in the past was we'd work on a site that was on a mountaintop with no road, and they'd fly you up in a helicopter and tell you to call when you're ready, and they'll come and get you. So you'd be by yourself. Take all your equipment up, take it out of the airplane, go do the job, measure everything, inspect everything, then call them back. And it worked, but of course now it's all different. The other thing that happened on the one that had the loose bolts on it in Kansas was one of the guy levels I'm looking at the tower, and one of the ways you measure guy tension is with the slope of the wire and the intercept of the tower. So if you're at the base of the anchor and you put up some kind of a scope on it, and you look and you see where it hits the tower, then you can actually equate that to the tension in the wire. So I'm looking at the wires, and one of the wires was just like real looped. I mean, it was clearly different than all the other wires, one level. So I went to the foreman of the crew putting it up, and I said, "You're going to have to fix these. This one set of wires is not right." He said, "I installed them myself. I know they're all right." I said, "Come with me." So I said, "Look," and he goes, "Oh shit." So they got them retention them. But so if you're on the side doing an inspection, uh, you'll do those intercepts and then compare to what they're supposed to be, and that tells you if the wires need to be adjusted. And you look for rust, and you check the grounding system and make sure it's intact. And you can actually measure the grounding system on a tower if you use the follow potential method. I don't know if any of you have seen that, but it's a method that where you go out about 100 feet, and then you take readings uh, every 10 feet or so, and then you plot a curve, and you can figure out what the ground resistance is. And I've done it many times. It works quite well. We were doing a tower in Florida, and I actually went out in the field, and because it's sandy soil, and I had them drive an anchor and a rod in the ground about 10 feet, and then did a photo potential on it, and it told me what the ground resistance was. And then I knew, because there was a spec that the ground resistance had to be 5 ohms or less. So so they had an inspector come out, and so anyway, I designed it so that I knew that if every rod had so many ohms, that if I had them in shunt, then I could get it down to five or less. So I did that, and I designed for 4. So the inspector came out, and he said, "No, you're going to have to measure this ground system." And I said, "I know. I'm prepared to do it. I'm going to do a follow potential method." He said, "Oh, okay." So we did it, and it came out 4.5 ohms. And he goes, "Well, you're going to have to do more than one run." And I said, "I am. I'll do another run." So I went 90 degrees around and ran another 100 foot and got about 4 ohms that time. And so he was now he was pissed, and he said, "All right." He said, "Well, you're going to have a PE write a report on this." And I said, "I'm a PE." And he says, "Why does that not surprise me? I'm out of here." He didn't like me. But careful measurements, you can very, very carefully design your ground system and measure it when it's done. So I'd recommend that as well.
Do you recommend any of these chemical ground systems?
Yes, we build them. The only thing about a chemical ground system is they have to be like every year or so, you should inspect them and load them, because the chemicals, as part of their grounding, they dissipate with moisture. And I've done that. We did the WNIN here in our public radio and TV. They have a 1,000-foot tower out near Booneville, Indiana. And we did an inspection on them about 2 years ago, and we ended up reloading all of their chemical grounds that they had with the compound that we stocked, and then they measured fine.
I would imagine in places where the ground resistance is rather high that this will solve some of those problems.
If you got a situation like that, like on a pure sand or whatever, putting in a chemical ground makes good sense, or at least having a couple of them somewhere. And then they would definitely work better than driven rod into sand. But again, if you go to a site and if you're having a work done on new tower put in or whatever, I would recommend that somebody goes and verifies what the ground resistance really is using the follow potential and a test rod. Then you can design very carefully to get the resistance you need. Some of them I've seen them spec as low as 2 ohms, but usually it's like 5. It works pretty well. That's about it.
Well, good. I think I pulled a picture up here that relates to something that you were talking about earlier, and I'll pop it up here to see if you would like to make a comment on it. Nope, that isn't it, is it? Let's try this again. Zoom's fighting a little bit today. Here we go. Try that.
Yes. Um, I'm not sure why they did that, but they ran a ground out to a guy wire. And you can kind of see that the tower where that is attached is a little rusted. What we'll do when we inspect, we'll carry cans of uh, of spray galvanizing solution of zinc, and you get to an area like that, and you sand down the surface and spray it with that zinc paint, and that's good for several years.
Hopefully get to it before it reaches that point.
Well, yeah, because it's you can kind of from the picture of the top picture it shows it. Um, it looks like it's corroded more than it is, but the truth is that dark spot there is actually the picture of the bracket they put on there. So what you'd have to do would be to take that whole thing off and then spray it and then put it back.
Mhm. Not the sort of thing you want to see when you go up on a tower.
Yeah, we've seen them, like for example, I've seen them with holes in the legs. Um, and we were taking one down in Florida to replace it, but it had a hole, huge hole in one of the legs on a 1,000-foot tower, about 100 feet from the top. So we actually brought some plates in and went up there and soldered reinforcement all above and below. It took the plates designed to fit that leg and split them, and then welded them all up, and then our engineers okayed it, and then we took it down.
You were mentioning earlier about water and freezing and insulators on a tall tower. What about base insulators?
It's the same thing. If you have a hollow leg, you need to have a drain hole because otherwise it'll develop moisture and build up. I've seen them before where they haven't done that, and eventually nature opens it up for us, and you'll see a hole in the leg at the bottom of the tower with rusty water coming out. That's not a good sign.
No, I wouldn't think so.
And, and of course, if you use solid rods, you don't have that problem.
Yeah. Had a question here in the chat box, and this had to do with well, several already have stacked up here. He says, "Is range testing about to be converted to drones?"
Range testing.
Taking a tower or an antenna and coming up with a pattern for that antenna on the range, or is that going to be converted to drone measurements?
We if I'm going to do it in the field, I don't want to use a drone. What I use is a 20-foot pole, and I have a mount that takes an FIM-71 antenna on it. I set the antenna for the proper lengths, tune up everything, and then I take readings and measure the field as I go out. And that works really well to look for a problem. And, is there a problem in the null? Is there a problem in the main lobe? Whatever. Um, I've seen them where I've showed up at the site and I've looked up and there's uh, a section that's wrong, so you have to go up and fix that. But usually there's good reasons for antennas don't work if they're not working. But
Lightning damage.
lightning damage, we often see it. It can it can be a painful thing. I've seen lightning damage where it makes holes in antennas and they start losing air, and you climb up there and and you can. I remember on Minnesota in Minneapolis, on the building there that has the multiplex antenna, and they asked me if I would come up and look at it because there was a major leak and nobody could find it. So I said, yeah, I'll come up and look at it. So I'm climbing the thing, and so I had him put a continuous pressure of 10 pounds on it. And when I climbed up the pole and got to the center of the antenna and listened, I could hear this shh. So then I just kept following it as it went up. So I went down one and it was gone, and I went up one and I could hear shh. So I kept going up and I could hear shh. Got all the way to the top, and I hadn't found any. It was going all the way to the end, and I was hanging off there right next to the stub. And all of a sudden I realized I was looking at the interconductor inside the stub through a lightning hole.
Ooh.
So before saying anything to anyone, I took a hose clamp and some stuff I had and put a piece of metal over it and took hose clamps and clamped it down. And I got this call and they said, "You found the leak?" I said, "Yes, I did." They said, "You need a new stub."
Well, I have a question about that in a second, but Pat followed up on his question about the drones, and he asked how much adjustment is possible by positioning and passive elements, and that's really something you need to do out on the test range, isn't it?
Yes. Yeah. You can model pretty well with Neck 4, but you can't do better than putting it on a table and turning it on a certified range.
To try to do it live out there when it's on a tower is probably going to take too much time and too much manpower to really be meaningful.
Well, we do it all the time. Because, of course, we're probably the only broadcast manufacturer that actually has an antenna range anymore. And we have it set up for a 200-foot path out to a receive antenna, and we can set it up for horizontal or vertical. And then we basically calibrate everything, and then we can turn it and measure the pattern. And we've done a lot of work where we've done a mathematical model and a turntable measurement and verify that everything works. For panel antennas, the neck is very accurate because they're so clean. The reflector screen has a 20 dB drop in signal from the outside to the inside. So you do get some inside of the antenna, but otherwise it's very accurately modeled using a computer because it's so clean. There's no, you don't see the members.
Well, with the computer modeling now, you can get a lot closer than the old days. The test range was the only way to do this, but now you've got the modeling and just like with phasers,
Yeah.
you can get them very close and then get out in the field and make the final adjustment.
That's correct, and we do that. It's like, for example, the getting FM onto an AM tower. There's two ways you can do it. You can use an isolation transformer at the bottom and have the isolation transformer next to the tower, and then run the cable from the tower to the output port and then have the input port the other end. And there's worked extremely well. At 425, the large one we do, I designed that when I was at Cornell one Christmas, and I've been making it ever since. But you can also go up a quarter wave with insulated standoffs, and then ground the cable to the tower into quarter wave, and now everything works fine.
Hmm. Brian Brasher says, very valuable information. I'm scheduling my inspections right away. Thanks. Thanks for the information. You were talking about the leak, the dry air leak, and I recently was asked to look in on a station where they had not bothered to check their dry air machine for almost 2 years. And of course, the crystals were not very good condition. But
Just as a rule, a site engineer probably once a week or more, if he goes out to the site, if he's working in the studio, for example, he goes out to the site, he should check the pressure gauge on the line. And, if it's all of a sudden zero, then he needs to address it.
for sure.
We had a situation recently where an engineer quit and he was pissed off. So he unplugged the dehydrator and nobody at the station saw it for a year. So for a year, the antenna had no pressure.
Well, now that leads to the question, here on the desert, we're pretty dry except during monsoon time. But what would the deleterious effects would you see as moisture builds, and can the engineers see this through the parameters, the measure?
If you don't have any leaks and you don't have any air on the antenna, it's not going to build up moisture because it doesn't have any way for the moisture to get in. But for example, I was hired to inspect an antenna that was having problems out in Oregon. And I got there and it was like 1,000-foot tower, and I climbed up the tower and I had some tools in my bag and everything. And I got, it was showing it leaking. Well, it really didn't leak except during storms. And then it started building up standing waves. So what I found was that the center feed flange, the crew that put it up, left the flange loose. So what had happened was that the O-ring from the pressure popped into the groove in the flange, and they showed that it was holding pressure. But every time they'd have a storm, the instant drop in temperature would suck the moisture in, and it started building up in it. So I found that flange and I tightened it up, and then I went to the bottom and I undid the stub at the bottom because the antenna wasn't on, and it was full of water, and I thought, wow, all this water came out. So then I took an element off, and it was full of water. So I drained it out and got it as dry as I could and put it back on. And then I took another element off the other side, and it was full of water. And I started working my way up, and the bottom two bays were full of water. And then when I finished up doing that, I suggested we put a vacuum on the antenna to pull the rest of the moisture out. So we did that and then put pressure on it, and everything was fine. But they were shocked that I found a loose flange. And that's the second time I've done inspections where I found a loose flange that was causing the leak, where everybody was inspecting antennas, but not finding the leaks. And then another one was down in the Midwest here, where the station owner asked me if I would come down because the crew couldn't find a leak. And I was working my way up listening, and I found the leak. I don't know why people don't find things sometimes.
Now, aside from the let's say rusting or other situations, how much will water in an antenna distort or destroy the field?
Well, the calculation for impedance, line impedance, is a function of the ratio of the ID of the outer to the OD of the inner. and it uses air as the dielectric. And if you replace air with water, it's a totally different dielectric constant, so it shows up as a standing wave. And like for example, uh, I was looking at a job for a guy somewhere in the Midwest, and he was having standing wave problems. So I put my gear on there and measured, and I calculated the distance to where the problem was, and it was literally right outside of the transmitter room. I'm trying to spot. It was right outside the transmitter, so I walked out and I took a tape measure to where my measurement said it should be, and the line was coming out, and the line went like that. So I said, in my opinion, this little loop is full of water. He goes, well, how do you know that? And I said, well, because this is where the problem is. And, it's got to be moisture. So he said, what are you going to do? And I said, well, I'm going to drill a hole in it and see what happens. He said, well, if the water doesn't come out, you're in trouble. I said, trust me, I'm pretty confident. So I took a drill out and drilled a little hole in that line it was the flex line. And it was like a cow pissing on a flat rock. The water just came flying out of it.
Yeah.
And then we ran a purge on it for more air, and then I cut the jacket off and soldered a little cover over it. It was fine after that.
Which
But
make a big difference in the coverage pattern in the end.
well, basically, it just makes the coverage pattern smaller.
Right. Well, Tom, I sure appreciate your being here. Anyone else have any questions that didn't get answered about tower inspections? I think one of the things I suppose is if you're sharing a tower, have you ever had problems with coordination or help from other stations that refuse to reduce power?
I don't blame stations for not wanting to reduce power because that's their livelihood. But yes, I have had issues sometimes with that, but worst case is I'll wear a suit. I remember one time I was on a tower out in Colorado, and the guy said, "Well, you'll have to climb through this one hot side mount TV antenna that they won't reduce." I said, "All right, I'll do it." And I was curious, so uh, it was night work, and I had a light on my helmet. And I got halfway through it, and I just wanted to see what it looked like. And I turned around and looked at it, and my helmet went poof, light burned out. I thought, okay, I'm getting out of here. So I climbed up. Fortunately, I always carry a spare bulb, so I changed the bulb out and finished the inspection. Didn't look at it anymore on the way down.
Well, there's no question that climbing through RF is a lot more dangerous than anyone realized years ago. And really, it's a matter of being cautious here. Why stations don't want to cooperate, that's a
Before they had the standards done, which Rick Tell did, and we were working on them, and they were on, and it was cold. I'd always climb over to an element and hold my hands down right next to it and heat my arms up. And it felt wonderful. It's forever.
Now
But
we've seen the pictures of you on the Empire State Building, and that's always late in the night, in early morning, and that's probably the smartest thing to do, isn't it?
yeah,
But it's more expensive.
well, yeah, but that's what you got to do. I mean, we don't mind working at night. I've been doing that for 60 or 70 years.
Uh-huh. Well, I guess the lesson is to budget for inspections and not wait until there's a problem where the guy
We do,
wire or
we
like
do the Empire State Building every year. They have us come out and do it. And there'll be 4 of us that'll do it. And we're going out in July to do that. And it's pretty neat. You take an elevator up to 104 and then you go up. You go up and you go up. Actually, you take an elevator up to as high as it'll go, and then you climb up the ladder to 104, and then you open the hatch, and you can either go out on the ice shield to do the aux because it's above the ice shield. That's a 3 bay, And it was designed by me. And what I did there was I was 100 feet closer to the people on the deck, but I was going to have every station on the tower in there at the same time. So I used a theory that I developed when I took a Stutzman Theo class out in California, week-long antenna class, and Tommy Vaughn from MCI had always said, if you use an even number of half waves, you get zero downward radiation. When I knew that was true, because every two bays are, they're they you rotate through the line at half wave, and then you flip one of the elements to get to 360 degrees, and so it's upside up, bump, 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 and they all add to zero every time, unless you put a null fill or something in. But I was wondering about that, and the reason is because you have two vectors. You have one vector this way and one vector this way. So I was looking at it, and I thought, well, what if you had a 3-bay and you build a triangle? Or a 4-bay and you build a box. So I had my computer set up and I started playing with it. And I came up with the n-1/n theory, where if it's a 3-bay, you use 2/3. It's a 4-bay, you use 3/4, and so on. And I ran it and it works. It goes to zero. So when we built that antenna for New York and set it up, we made the reflector screens on the 4 faces out of 1/4-inch steel, so that you could climb through it, because if we'd used a screen, it would leak minus 20 dB and that would expose people way too high. So then we got there, and the crew came in to do the measurements on the deck. This is the middle of the night, there were no tourists there. And we had everybody on the building on the new aux. And the guy that was going to read them, he told me, he said, I can tell you right now, this isn't going to meet. I said, well, let's measure it. So we're measuring away, and he goes, and so that we finished most of the deck was below the level. He couldn't believe it. So he said, sorry, well, I'm going to tell you right now, the highest part of the building right now is the northwest corner. We're going over there next. And I can guarantee you it's not going to meet. And I said, well, let's go measure it. So he's waving the wand around. I said, what the hell did you do up there? So I told him, build a triangle in 3 vectors. And it works.
That's really interesting. And you raise an issue here, or a question in my mind. I'd love to ask you to come back another time and talk about antennas in that sense of the spacing, the horizontal, the vertical, and those aspects. I think that's fascinating.
Well, what's really neat is I replaced one on South Mount out north of Denver, west of Denver. And the one that was up there, it was radiating and exposing all those people. And the people on the mountain actually own a measuring device, and they complained that there was too much radiation coming off of it. So I got hired to go out there and verify it. And what I found was that the antenna was radiating way too much downward. And so I ended up quoting another antenna using the theories that I have. But like, for example, if you have a 5-bay and you have to have 4/5 spacing to get zero downward, what you can do is you can design your block on your element so that the input's on the side and not the bottom. And then you put a phasing device there, like an elbow, and then your interbay line off to the side and then back in, and now you get 360-degree rotation. So you get zero downward radiation plus no problem with the interbay.
John, you kind of asked a question in that area. Is that
Oh, yes. Can you hear me? Yes.
Yep.
All right. Yeah, you mentioned that Empire n-1/n wave spacing. I'm curious to know, can you use that with a multi-station combined situation? And if so, which frequency do you use to set that spacing?
When I have a situation like that, what I'll do is let's say there's 4 frequencies.
Yeah.
I'll add them up and divide by 4 and find out what the center is, and then I'll design the day spacing for that frequency.
So in other words, the frequency at the exact midpoint between the two edge frequencies.
Or, well, yes, pretty much. And that works pretty well because, it works better than if you just used a standard full wave spacing. But it's not as perfect as it would be for a single station.
It would probably work best on the frequency that's closest to that center.
That's correct, as far as downward. But honestly, they work pretty well.
All right, thank you. It's very curious and very informative.
Thank you.
Tim Adair asks, how much power savings can you have from moving 3 bays to 4?
I'm sorry, what?
How much power savings can you gain by moving from 3 bays to 4?
Well, your gain of the 4 bay is higher than the 3 bay. I could tell you exactly, but I can't use my computer with you on my screen. But it's interesting. The program we use to measure FM antenna gains and different spacings and everything it's a real neat computer program. It's actually one that I wrote years ago. And I remember when I first started doing field work, I talked to my father about it because he owned the company then. And of course, he's unfortunately passed away, but he was a brilliant engineer. And I said, because the guy that was teaching me and out here at Curly Green, he said, well, what you do is you just measure the antenna and then you have them move the slug around until it works. And then if you need to try different sizes, so you spend all this time. And I said, why can't you calculate that? And my dad said, well, I'm sure you can, but I don't want to do it because I don't do that. So I said, I'll do it. So I worked out the formula where you measure the open circuit and then you measure where the slug is and you can calculate exactly what the impedance is at the slug, and then you can take the slug out mathematically and move it and put it back in mathematically, and they'll tell the crew what to do. And a lot of times you'll do it with one shot. It's a lot more efficient.
That
We
answer
have
your
a s-
question,
we-
Jim?
Kind of, yeah. We have a station in the Virgin Islands, and power in the Virgin Islands is like 54 cents a kilowatt hour, as opposed to 15 cents a kilowatt hour here in the States. And wanted to see what we could do to reduce the input into the transmitter and potentially save what could be substantial if it's worth the extra switching from a 3 bay to a 4 bay antenna.
Basically, what I would do there is I'd calculate the exposure on the ground, and you can do that pretty well. And then because you want to have enough signal on the ground that people can listen to your radio station. The 4 bay probably wouldn't make much difference to a 3 bay.
Correct me if I'm wrong, Tom. In my memory, a 2 bay is roughly an even 1 ratio. 6 bay is 3. So 4 bay might be a 2.5.
The 4
So
bay
not much.
4 bay would be a 3/4 wavelength spacing to optimize the downward radiation to 0. But you're trying to cover on an island, and you might not be typically worried about the RF exposure because maybe you're up on a hill and there's no
We
one up
are.
there. So
Now,
what you're doing is you're evaluating what the elevation plot is for the array. And so, you get your main lobe and then null fill and then your minor lobe, and you see where that is on the people.
what are the questions that would align with that? What about single sideband FM? Would the power savings there be substantial?
With the IBOC, you mean?
No, sort of taking that L minus R and doing that single sideband, or what is it now? Is it Worldcast? They have a smart FM program to reduce power.
I have that program, yes. But what I'll do is I'll know what what the terrain is and where the people are. And then I'll run it and like I'll calculate what the exposure is and everything and
You,
what the,
you make a good point, because if you're on an island, you don't want to overshoot your audience, but
correct.
maybe the single sideband would save some power.
Single sideband. I'm not sure what you're talking about.
Again, the L-R, which is a dual sideband AM, right?
Oh, AM. Okay.
And so if you
I'm
eliminate,
sorry, no, we're FM.
no, we're talking about FM. We're talking about the L-R on FM. And if you eliminate half of that, you would conceivably save power.
I'm not sure that that would be something you'd want to do, to be honest with you. But I'm not a transmitter designer. I'm where the energy goes designer.
You're channeling Leonard Cohen.
What's that?
I said Barry's channeling Leonard Cohen with sideband.
Talking about the stereo, the subcarrier for stereo, that's only going to impact your deviation, not your power.
Yeah, what I would do is I wouldn't try to do something at the transmitter. I would do something with the antenna gain. But you know, that's what I do. I don't do transmitters.
All right. Any other comments or questions, folks? We're going to have to let Tom get back to his afternoon here.
Well, the highest I've climbed is to the roof of the World Trade Center, the old one, and I still glow at night. You were mentioning the chemical ground system. How would you reload that?
You basically you have to have them in the ground so that the top of the PVC tube that the stuff's in is right at it has a little cover over it, right at the top of the ground level. And then you take that cover off and then you just dump it in there. So that's the way we do it. But you have to be able to restock them because otherwise in 5 years there's no ground.
So whether you're dealing with chemical or you're dealing with ground rods, these things have to be checked.
Yeah, right. Now, if you're using a ground rod, it's not a bad idea to, you know, if you do the inspection to have them measure your ground system too. And there's two ways to do that. They make a clamp-on meter that Lincol has that you clamp onto the wire and it tells you what the impedance is. Or you can do the fall potential and set up a path and you just go take the readings and plot them and it will tell you what the ground resistance is.
Well, for those of you that need to have an inspection done, the folks at ERI are ready for you.
We and others can do it, yes.
Tom's got the guys, he's got the experience, and I got to tell you, I've not been above the transmitter floor on Empire, but I was on the top of another building with Tom, and the one thing you got to know, he is safety conscious. No two ways about it.
Well, you know, somebody mentioned the World Trade Center. I worked on both buildings before the one came down. And then when the other building, when they were replacing the World Trade Center, the MTVA of New York, Metropolitan TV Association, they put together a team, and Oded Bednov was on it, I was on it, and several others. We had I was there for both structural and antenna, and we worked every month. We'd have a meeting in New York as the building started going up to talk about the work on the top. And the tower design was given to another company, and so but I wanted to look at the data. And Tishman contractors were given the job of putting the new one up, and they came to the meeting and they were talking and they said, "No, we're going to use a tower crane that we can pick 10,000 pounds." And I said, said, excuse me, but are you aware of what these sections are going to weigh?" And I said, "Well, I'm assuming they won't weigh more than that." So, well, the bottom one weighs 25,000 pounds. So I said, "Oh, damn." So what we had to do is we designed a custom tower crane that's in a storage in New York somewhere. It's only been used one time, and that was on that trade center. So anyway, when it finally got done and everything got put up and they took the tower crane down, nobody had ever climbed the tower. So I got a call and they from one of the building managers, and they said, "Tom, can we hire you to climb the tower?" I said, "Sure." They said, "Nobody's ever climbed it and people are getting nervous." So I said, "Well, there have to be two of us. I'll be glad to do it." So they said, "All right, we'll have a meeting for you first, and then you can go climb the tower." And then and I brought Dave Carter with me. He was a guy I worked with 3 years. He was a union iron worker. And so we went to the meeting, and they had all the guards there in a room. And the manager said, "Now you have to have everything you carry tied off." And I reached down to my briefcase and pulled out a notebook on a string. I said, "You mean like this?" He goes, "Okay, all right." So we went over to climate, and we got the fall protection was the kind that you hook a little sliding rail hook on, and then you ride up that on your belt so that you can't fall. And if you start to fall, it grabs. But the problem was that to get on the bottom one, you had to go on the floor below the top of the building. And then they had a hole there, and you'd climb through that hole, but they had it all boarded off for construction work. So you couldn't get on the thing. So the guy with me said, "Well, what are we going to do?" And I said, "Well, we're going to climb up to where we get on there, and we're going to we're going to start whacking our hooks on it. And we'll just climb up till we get to the next switch over, about 3 or 4 sections up, and then climb over. And then we'll be on it the rest of the way." Said, "Okay." So we got all the way to the last section where the light is, and so Ed said, "Well, let me go up first. I want to take a look at this." I'm standing down there on a walkway about 20 feet below where the hole is to go in there. And he climbs back down. He says, "We can't get in there with our belts on. The hole's too small." So he said, "We'll have to free climb up there." And I said, "Ed, if we free climb up to that hole and anybody sees us, we'll be banned for life from working on this building. I don't want to do that." So we climbed down. But I remember when we first started climbing, the guard said, "So you're a crazy sumbitch, you know that." I said, "I've been called worse." But it was pretty neat to be the first climbers to ever climb it. Very enjoyable.
Well, Tom, I could listen to you all afternoon. And again, I know you've got other things to do, and I'd love to invite you back again later, maybe another time, and tackle another aspect of antennas and towers. But I sure thank you for being with us today.
Well, thank you for inviting me, Barry, and thanks everybody for listening in. If nobody has any questions, we can end the meeting.